All right, so example 4, solve x equals the square root of 2x plus 3, identify any extraneous solution. So on Friday, we didn't have a whole lot of we didn't have any extraneous solutions in our example problems. I don't remember if any happened in the homework or not, but it was something I really was getting after you about. You need to check to make sure these things actually work. The ones we saw on Friday, they don't typically have extraneous solutions unless it's just a ridiculous problem to start off with. These problems that x is outside and inside the radical, they're more likely to lead to extraneous solutions. So checking our answers is going to be key on these problems. We need to make sure we do it. The basic technique is not any different than what it was before. The difference will be when we get to the equation part, the equation will be a little more complicated than it was before. And what you'll notice here is we have x equals the square root of 2x plus 3. The radical is right here. Step 1 is to isolate the radical, and as you can see, the problem starts off in isolated form. Radical is all by itself, right? There's nothing being added to it, subtracted from it, multiplied or divided by it. So this is what I'm looking for to start off with on these problems all the time. So I'm just going to go ahead, this is in my book, I copied my paper exactly as it's written. So x equals the square root of 2x plus 3. Again, there's nothing to do as far as isolating the radical because it already is. Step 2, I now want to square both sides because this is a square root. So this is a square root. Again, if no root index is written there, it's understood to be a square root. If I have a square root, I need to square to fix it. I've got to square both sides. So on the left-hand side, on Friday, we had a number squared, we'd evaluate it, and here we have a letter squared. All I can do is write letter squared. There's no way to evaluate x squared. We can just write it down as x squared. We simplify what we can to the extent we can. The right-hand side is just like it was the other day. We have a square root squared. The square root and the square undo each other, leaving us with the contents, which is 2x plus 3. So again, going back to Friday, we would have had 2x plus 3 equals some number solved for x, linear equation. Well, now we have x squared equals 2x plus 3. Now we have a quadratic equation. When the highest power of an equation is 2, we want to set everything equal to 0. That's our typical technique for solving quadratics. Set the equation equal to 0. So I'm going to take the 2x and the 3 over to the left. X squared staying where it's at, stays positive. 2x moves left, becomes negative. 3 moves left, becomes negative. Everything came off the right-hand side, so there's nothing or 0 left on the right-hand side. So x squared minus 2x minus 3 equals 0. So now we're in quadratic equation world. And again, when I look at a quadratic equation, I'm looking for how many terms, in this case 3. I'm looking for lead coefficient, in this case 1. When it's 1x squared and it's a trinomial, I'm looking for numbers that multiply to make negative 3, that add to make negative 2. Those numbers are negative 3 and positive 1, right? Yeah. So parentheses x minus 3 times parentheses x plus 1 is the factored form of x squared minus 2x minus 3. Once I successfully get the factored form, now I can set this thing, each factor equal to 0. So either factor 1, x minus 3 equals 0, or factor 2, x plus 1 equals 0. And each of these is just a basic linear equation. Move the number over, change the sign to get the answer. So for the first equation, if I move the negative 3 across, it becomes positive 3. So 0 plus 3 is 3. For the second one, move the positive 1 across, becomes negative 1. 0 minus 1 is negative 1. And what we've created here is a list of answers that are possible solutions to the problem. They may or may not be correct, but they're the only numbers in the world that could possibly be correct. Okay, so these are, again, the solutions we got through the technique. But again, when we do this step in the technique right here, it sometimes allows us to get answers that are not allowed to be answers to the problem as answers to the problem. So the last thing I have to do, just like on Friday, is I go back to the original problem before I started messing with it. So go back here. I'm going to change each x that I get into these two numbers. So I have two numbers to check. First one is x equals 3. The second one is x equals negative 1. Again, for it to be correct, exactly as it's written, has to be equal to each other. The left and right hand side the same. So if x equals 3, and I'm replacing both of these x's with 3's, I'm going to get 3 equals question mark square root of 2 times 3 plus 3. Okay. This x and this x became this 3 and this 3. Because I'm testing x equals 3. Okay? The only thing I have to do is work out this side. What's 2 times 3? And 6 plus 3? Does 3 equal the square root of 9? Sure does. So 3 is a good answer. Okay, our other solution we have to check out is -1. So I'm going to replace this x and this x with a -1. So -1 equals question mark square root of 2 times -1 plus 3. 2 times -1 is? And -2 plus 3 is? 1. 1, so -1 equals the square root of 1, does it? No. No. It's positive square root of 1. So back when we were doing these before, let me just show you something real quick. If x squared equaled 1, then x would equal plus or minus 1, right? Or plus or minus the square root of 1. So x would equal plus or minus 1, right? So the square root of 1 is either positive or -1. If you introduce the square root to the problem, you have to put the plus or minus sign there. If the square root's already in the problem, if the square root's already in the problem like this, it's the sign is what it is. So this is a positive square root, this is a positive square root, so this equals +1. This is -1. Those aren't the same number. And if those aren't the same number, that means this answer is illegal, cannot be included in our solution set. So the only correct solution to this problem is x equals 3. Again, that's much more likely in the problems we're seeing today than we saw the other day.
How do we feel that it's illegal to scribble it out?
Well, you just throw it out, or just like when you write your final answer, just write x equals 3. Don't write -1. Any answer that doesn't work, it doesn't get to be included in your solution set. So when you write your answer, x equals, here's all the answers. And you list all the answers that work. If one doesn't work, you throw it out. If all your answers don't work, which is unlikely, but if all your answers don't work, the answer is the empty set. Circle with a slash through it, there are no solutions. But more often than not, at least one of the answers, sometimes they both work, sometimes only one works, almost all the time only one works, but then occasionally both of them don't work. That's not very frequent.